Before we get started on today's lesson, we're going to look at problem number 20 from 3.1. Now, problem number 20 on 3.1 says if there is a line and a point not on the line, then there's exactly one line through the point that intersects the given line. Well, okay, so let's look back. Alternate exterior, alternate interior. Okay. The perpendicular blind postulat states if there's a line and a point not on the line, then there is exactly one line through the point that is perpendicular to the given line. Because if we just have a point and a line and they intersect, well, there's lots of ones that we can draw. Because any line that's not parallel, because there's only going to be one parallel line through that point, and there's only going to be one perpendicular. Any other line that isn't one of those two would eventually intersect the given line. So there's infinitely many lines that will intersect it. So, number 20. The reason this is wrong is it's not that there's exactly one line through the point that will intersect the given line. Exactly one line through the point that's not intersect, but that will be perpendicular to the given line. Because if there's a line and a point not on the line, then there's exactly one line through that point that is perpendicular to the given line. Because it's really coming down to the fact that if we have a point and a line, there's only going to be one line that's perpendicular, and there's only going to be one line that is parallel to it. And this here is at the foundation of Euclidean geometry, not so much the perpendicular, but the parallel. Is the fact that given a line and a point, there's exactly one line parallel to the given line, is what defines all Euclidean geometry. Because any non-Euclidean geometry, that does not hold true. It doesn't hold true. Either there's more than one or there's none. It would define most non-Euclidean geometries. But any other questions on the homework assignments? Besides that one there. 3.2, question 10. 3.2, question 10. Okay. Keep going. Point 2. Okay. Nine, 10. Solve for the value of x. So we look at this here. Question number 10. Is 118 and 8x plus 6, are they corresponding angles? Alternate interior, alternate exterior. Well, they are alternate, yes? So alternate exterior means that they are going to be both outside the parallel lines. Well, are they that? Well, 118 is outside. Is 8x plus 6. No, so they're not alternate exterior, they're not alternate interior because they both have to be between the lines. So they're neither one of those. They're not corresponding. So they're not going to be congruent. But we do know 4 and 8x plus 6 are alternate interior angles. So really this here is 8x plus 6. So I do know that these two here add together to be 180. So we can say 8x plus 6 plus 118 is equal to 180. Because when we have two parallel lines cut by a transversal, the angles are either going to be congruent or supplementary. So at this point here, we can add our like terms. So our 6x and 118, which would be 124 is equal to 180. At this point here, we would subtract 124 from both sides, because those would simplify, telling me that 8x is equal to 3 and then we would divide both sides by 8, telling me that x is equal to 7. And that's all we need to do for this here. Yes, sir. Okay. So if we look at number 12, so we're looking for the measure of angle 1, measure of angle 2, and the measure of angle 3. We're looking at these here, 133 and the measure of angle 2 would be the exact same because they are alternate interior angles. Now, 2 and 3 add together to be what? 180. So to find angle 3, well, I can take 180 and subtract 133, and that would be 47 degrees. Any questions on how we found 2 and 3? Now, 1, if I ignore this line here, wait a minute, I have two parallel lines, yes? Cut by a transversal. Well, 1 and 3, alternate interior angles, yes? So it means that they are congruent, so angle 1 is 47 degrees. It doesn't matter how many lines we have, as long as they are parallel and cut by a transversal, these properties will hold true. Any other questions on this here? I mean, it would be, I'm fine without it, but it's really, we found 1 because alternate interior angles with angle 3. 2 and 133 are alternate interior. And 2 and 3 are supplementary. I mean, it's just using those there. No. You can write it out if you want, but I'm not going to count off for it, because it just helps me better know that you understand it. Any questions on this here? Okay. We good with this here? Okay. Have that go away. And quickly. Let's see here. 4 through 10 even, and 11 through 13. So what we went over yesterday, thank you, was corresponding angles, alternate interior angles, alternate exterior angles, and consecutive angles. Now, if we were looking at this here and we wanted to name the corresponding angles, well, we would have angle 1 and what? 5. Because corresponding 1 and 5 correspond to each other. They're in the same location. So 2 and 6. Yep, angle 4 and angle 8, because they correspond to each other, and they would be congruent since the two lines that are being cut by a transversal are parallel. Our alternate interior angles. Not 1 and 4. 4 is 1. 4 and almost 5, because alternate interior. Interior means between the two lines and on opposite sides of the transversal since it's alternate. So 4 and 5, and then 3 and 6. Alternate exterior would be 1 and 8, and then 2 and 7. Now our consecutive angles would be 3 and 5, and then 4 and 6. And this is the only ones that would really describe as being consecutive, because we talk about the consecutive interior angles. I mean, we could work through and show that 1 and 7, angles 1 and 7, 2 and 8, do have the same property. They're going to add together to be 180. Any questions on this here so far? Now, what we talked about yesterday, we started off with saying what? If two lines are parallel and cut by a transversal, then the corresponding angles are congruent, yes? Well, we're going a little bit different route today. We're going to talk about the corresponding angle converse. Well, the converse was taking our conditional statement and flipping the hypothesis and conclusion, yes? So the original statement for corresponding angles was if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Well, if I flip it, we're going to start off by saying if corresponding angles are congruent, if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So if two lines are cut by a transversal and the corresponding angles are congruent, then the lines have to be parallel. That really means that we have a biconditional statement. Because if the corresponding angles, if corresponding angles are congruent, then the lines are parallel. If the lines are parallel, then the corresponding angle should be congruent. So, find the value of x that makes these two lines parallel. Because if the two angles, these corresponding angles, are congruent, then the lines have to be parallel. Well, 3x plus 5 and 65 degrees are corresponding angles, yes? So if I want the lines to be parallel, those must be the equal. They must be the same. So what we're saying is that 3x plus 5 needs to equal 65 degrees. Because if these two have the same measure, then they're going to be parallel lines. Then the lines will be parallel. And we just need to find what value of x will make 3x plus 5 be 65 degrees. So we'll set them equal to each other and solve for the value of x. Now what can we do first? We can subtract 5 from both sides. And we subtract 5, well, the 5 minus 5 will cancel, leaving us with 3x is equal to and what would we do next? We would divide both sides by 3. And 3x divided by 3 is going to be x. And 60 divided by 3 is So the value of x that makes these lines parallel is 20. And that's it. That's all we have to do for this here. Questions on this here? Find the value of x that makes these lines parallel. So 72 and 4 times x plus 5 are those corresponding angles? No. Because 72 is to the left of the transversal and above the line. Our 4 times x plus 5 is to the left of the transversal, but it is below. So those are not in the same place. But since 72 is to the left and above, this angle right here, which is to the left and above, would be corresponding. Because if both of these are 72 degrees, then we can say they are parallel. But we can also see that these two angles do what? They make a straight line, yes? So they should add together to be 180. So we can say that 4 times x plus 5 plus 72 is equal to 180, because these two angles need to add together to be 180 degrees. What can we do first? Distribute the 4. We're going to multiply it by the x and the 5. Well, 4 times x is 4 times 5 plus 20 plus 72 is equal to 180. Yes, we can combine like terms first. So the 20 plus 72 would be 92. Yes, so we're going to subtract 92 from both sides. There's 92 minus 92 would cancel out, become 0, and all we're left with is 4x. Now, 180 minus 92 would be 88. Because the 8 plus 2 would give us 10, so 0 carry the 1 over to the 90. Well, 90 plus 1 is 100. So the only thing we're left is an 8, adding up to it. Divide both sides by 4. X is equal to 22. So the value of x that would make these lines parallel is 22. And that's it. Questions on this here? Any questions on any of this here? Is there enough information in this diagram to conclude that the two lines are parallel? Well, 75 and 105 are not corresponding angles. They're not alternate interior, alternate exterior angles. So they do add up to be 180. Now, one thing I can say as well, the angle above 105 is 75, because two angles that make a straight line will add together to be 180, because we know that, because that's the definition of a linear pair. Well, that means that these two angles are corresponding, yes? So if there are given two lines cut by a transversal, if the corresponding angles are congruent, then the two lines are congruent. So is there enough information? Yes. We can show by the corresponding angle Converse theorem, I believe. that these two lines are congruent. Any questions on this here? Are you ready for what's next? Now, I know that there is this part to explain why the corresponding angle converse is the converse of the corresponding angle. We really already talked about that because the original statement was given two parallel lines, then the corresponding angles are congruent. Its converse as well. Given that the corresponding angles are congruent, then the lines are parallel. We flip it. And I think this is already written in for you. And it's really just what we already had so far. Our alternate interior angles converse. If two lines cut by transversal are cut by transversal, so that the interior angles are congruent, then the lines are parallel. Alternate exterior. Two lines cut by transversal, so that the alternate exterior angles are congruent, then the lines are parallel. Consecutive interior angles. If two lines cut by transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So if we have any one of these properties holding true, then the lines have to be parallel. You won't have to actually do a proof, and I don't know if this is in your note sheets on the next page. Okay, because we're going to work through it, and kind of this helps us see that this is true. Well, with any proof, we always start with what? Given information. And we know that we're going to finish with proof. And the reason at the end is not going to be proof. It's actually going to be something different than proof or proven. So I do know that angle 4 is congruent to angle 5. And we want to prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Well, we know so far, because we've already shown or kind of worked with the fact that the corresponding angle theorem does work, yes? The corresponding angle converse. Well, if 4 is congruent to 5, we also know that 1 is congruent to 4. Because 1 and 4 are vertical angles. Because vertical angles are congruent. So we can say that. And that's really given to us from the picture and also knowing about vertical angles. Well, if we said 5 is congruent to 4 and 1 is congruent to 4, so what can we say? Does it have two statements with an angle congruent in the middle? We can say 1 is congruent to 5. Transitive property of congruency. And we could also be specific and say transitive property of angle congruency, because we're talking about angles. But that works as well, the transitive property of congruency. Corresponding angle converse. Now, once we've proven or shown that a property is true, or a theorem is true, so the corresponding angle converse, we've shown that's true, so we can use it. Well, now we've used it to show that the alternate interior angles are congruent. So then we can just use it from here on out. Okay? Now, what you'll see and what we've kind of worked with so far is, well, given two lines, to find the angles with a line cutting through the middle of them, we would really need to at least know one angle on both. Because given vertical angles and linear pairs, if I knew one angle of a line being cut, like this here, if I knew at least angle 1, I could find the rest. But before this chapter, I couldn't say anything about angle 5 or any of the angles connected with it. So I would need to know 1 and 5. I need to know two angles, one on each line. Well, heck, now if I know that one angle and that these two lines are parallel, I'm given just those two pieces of information, I can find the other 7. That's kind of nice, isn't it? Because a little bit that we've discovered with these properties has taken us from pretty much I had to, before even the beginning of this class, I would have to have a protractor and be able to measure every single thing. I'd have to actually measure the angles. Well, now we moved on to vertical angles, where if I measured one, I could find the rest, given the properties. To now, well, okay, the lines are parallel, and I know the measure of one angle. Now I can find 7. So this is slowly giving us tools and resources to where I'm needing what? Less and less information, and I can find more. I'm able to use these to find a lot of stuff out with very little information. That's what's nice or really cool about mathematics and what it gives us the tools for. In the diagram, R is parallel to S, and angle 1 is congruent to angle 3. Prove that P is parallel to Q. Okay. So we're told that R is parallel to S, and 1 is congruent to 3. Well, you can say R is parallel to S, given. And angle 1 is congruent to angle 3, which is given. Now, P is parallel to Q. Is what we want to prove, yes? P and Q are parallel. Wait a minute. If P and Q are parallel to each other, we need a line cut by a transversal, dealing with alternate interior, alternate exterior, or any one of those sets, yes? Now, I can treat S or R as a transversal, because a transversal is just a line that cuts. Yes? Well, I'm already given a statement about 1 and 3 being congruent, yes? Well, say P, Q, and S. Well, if I know that 1 and, let's just call this 4 for now, because if I knew that those two angles were congruent, alternate interior angles, I could use its converse to be able to say that those two lines are parallel, yes? Okay. Because that'd be a good place to start. So I would need to be able to say something about 4, that angle, yes? Wait a minute. We already know that these two lines, R and S, are parallel, yes? And they are being cut by a transversal. So what is 3 and 4? They're what type of angles? You might have to turn your head a little bit because it is kind of tilted to the side, isn't it? Corresponding, aren't they? Because, I mean, if we look at it that way, but because the two parallel lines are going up and down, yes? So given the two parallel lines and the transversal, 3 is outside and below the transversal, yes? So 3 is to the left of the line and below the transversal. 4 that we drew in is to the left of the line and below the transversal, yes? So 3 and 4 are actually congruent. Angle 3 is congruent to angle 4. Why? Our corresponding angle theorem. The corresponding angle theorem says if two parallel lines are cut by a transversal, then the corresponding angles are congruent, and that's what we have, yes? Wait a minute. In step 2, I said 1 is congruent to 3. That's what we were given, yes? We just said 3 is congruent to 4. So that means I can say what? Angle 1 is congruent to angle 4. This is our transitive property of, not equality, congruency. One is congruent to 3, 3 is congruent to 4, so 1 is congruent to 4. Transitive property of congruency. Yeah, because we're past proofs. We're not going to do proofs again, because I'll show proofs to help better illustrate and why this works, but y'all are not going to have to do that again in here. So, alternate interior angle converse. That is, if two lines are cut by transversal so that the alternate interior angles are congruent, then the lines are parallel. And that's how we could go about proving this. Questions on this here? Okay. Yeah, I'm not going to make y'all sit through another proof. The next theorem that we have, Theorem 3.9, the transitive property of parallel lines. If two lines are parallel to the same line, then they're parallel to each other. So if P is parallel to Q and Q is parallel to R, well then R is parallel to Q. Because if two lines are parallel, they're never going to get any closer, they're never going to cross. If those two are parallel and never cross, or parallel to a different set, well, none of them are going to cross. Because if P and Q are not getting any closer together, so they won't cross, and Q and R aren't, well, then P and R aren't either. So in the diagram, P is parallel to Q, and Q is parallel to R, so we know that P is parallel to R. They're all parallel to each other. So we can use that to find the measure of angle 8. So is 118 and 8, are they corresponding, alternate interior, alternate exterior, or consecutive interior angles? Or none of those? Because is 115 and 8 on opposite sides of the transversal? No, so it can't be alternate interior or alternate exterior. Is 115 and 8, are they on the same side of the transversal and both above or both below the line? No, so they're not corresponding. Consecutive interior means they would both be inside the lines, well, they're not. So technically, this would be consecutive exterior if we actually had that property. So most likely what that means is angle 8 and 115 do what? They add together to be 180. So to find it, well, we could say the measure of angle 8 plus 115 is equal to 180. Well, what would we do? We would, from 180, which would tell us that the measure of angle 8 is just 65. Because that would be 7, 10, 10 minus 5 is 5, 7 minus 1 is 6. So we get 65 degrees. Yeah. Because even though we do have multiple sets of lines, the property still holds true. Because again, all of these properties corresponding alternate interior, alternate exterior, and consecutive interior angles is dealing with what? If two lines or if two parallel lines are cut by a transversal, then the following thing would hold true. Yes, either corresponding Corresponding would be angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding interior angles are supplementary. Because what is it? Two parallel lines cut by a transversal. Even though we have one in the middle, do we still have two parallel lines being cut by a transversal? Well, yeah, so it still holds true. And this here, I believe, is the last one. The United States, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom. Well, each stripe is parallel to the one below it. So we know that S1 is parallel to S2. You don't have to write this out because we also know that S2 would be parallel to S3. S3 is parallel to S4 is parallel to 5. S5 is parallel to S6 is parallel to 7. Well, 7 to 8, 8 to 9, 9 to 10. Well, then we know that S12 is parallel to S13. So therefore, because of our properties of parallel lines, we can say that S1 is parallel to That's it. That is all we are doing for today. So on page 130, 3 through 8, 11 through 16, 21, and 22. Okay. Thank you. Now 21 and 22 are AC, line AC and DF parallel. Explain your reasoning. So you need to explain using alternate interior angle converse, alternate exterior angle converse, corresponding angle converse, or supplementary, and using those properties to be able to say that either yes, they are parallel or no, they are not. So saying yes and no will give you partial credit, but I need the full thing. Okay? So on those, you'll need the full explanation for those. Also, Monday, we are going over 3.5. We are not doing 3.4. We're going over 3.5. Tuesday will be the makeup day. Wednesday will be the review. And then we come back from fall break on Tuesday. We will go over the review, and Wednesday will be the test. Huh? Because of fall break. Okay, because I can get, if you're ready for it, I can get the test to you.